Question number 13. The temperature of water at the bottom of waterfall is greater than the temperature of the water at the top. The energy in the gravitational potential store of water at the top is transferred to the thermal store at the bottom. The specific heat capacity of water is 4,200 joule per kilogram Celsius. What is the temperature difference for waterfall of height 21 meter? We know that gravitational potential energy mgh equal thermal energy with mc delta T. M is the mass, G is gravitational potential gravitational strength, H is the height, C is the specific heat capacity, delta T is the difference in temperature. So we cancel M with M and divide both sides by C, left delta T equal G H over C. This equal 9.8 times 21, the height is 21, over specific heat is 4,200 joule, and this equal 0.049. So the correct answer is number B. The correct answer is number B for this question. Question number 14. An ice cup is placed in a beaker and is heated. The ice melts to form water which evaporates at first and then boils. The steam condenses on a cold window in the room. Which process involves a transfer of energy from the ice, water, or steam to the surrounding? Number A, melting, not correct, because melting absorbs energy or takes energy. Number B, evaporating, also it's absorbed or takes energy, not correct. Number C, boiling, also absorbed or takes energy, not correct. Number D, condensing, yes, this is transfer energy because it lost energy to the surrounding. So the answer is condensing, number B. Question 15. A teacher shows his classes a polystyrene cup. The polystyrene is a thick plastic with lots of tiny air bubbles in it. He takes the class why. He asks the class why the cup is so good at keeping a hot drink warm. 3 suggestions are made. It contains air, which is poor thermal conductor. Correct, because air is a poor thermal conductor. Number 2, the air trapped in a tiny bubbles, so very little convection is possible. Also, this is correct. Number 3, the plastic is a poor thermal conductor. Plastic is a poor thermal conductor. Also, this is correct. So, which suggestions are true? Number A, 1, 2, and 3, all of them. Yes, this is the correct answer. Question 16. 2 samples of same materials have the same mass, but different surface area. They have same mass, but different surface area. Each sample is heated to the same temperature. They heated to the same temperature and then left to cool to room temperature, cool to the same degree. Each sample is allowed to cool to the same final temperature. This is the small surface area X and Y is the large surface area, which correctly compares the decrease in internal energy and the initial rate of cooling for each sample. We know that the decrease in internal energy for both objects is same. And initial rate of cooling, the object that has the higher or large surface area will cool faster. So we will look for this in our answer. X losses more internal energy than Y. This is not correct. X cools faster than Y. Also not correct. X is small surface area, so it will not cools down fast. Y losses more internal energy than X. Also it's not correct because they will lose the same quantity of energy. Y cools down faster than X. This is correct, but here number B is not correct because one correct and other is not correct. Number C, X and Y lose the same quantity of energy. This is correct. While X cools down faster, X is small surface area, it will not cool faster. Number D, X and Y lose the same quantity of energy. Yes. Y cools down faster than X because it has large surface area. So the correct answer is number D. The correct answer D. They will lose the same quantity of energy, and Y, which has large surface area, will cool down faster.